Today's video is going to be about chlorination. We're going to be talking about the overall reaction, the product of the reaction given the certain reactants and the conditions of the reaction, and we're going to be talking about free radical reactions, which is the type of reaction that happens with chlorination. We're going to be looking at different steps of a free radical reaction. As we get into it, it's important to know what chlorination actually is. So chlorination is some sort of process or reaction where chlorine is added to some sort of molecule, and it's only chlorine that's added to that molecule. So for example, for year one, you might understand, so chlorination of an alkene by electrophilic addition of Cl2, like you're adding a Cl2 group. So that's chlorination because you're adding just chlorine. Or for year two people, you might understand chlorination of a benzene ring by electrophilic substitution to maintain aromaticity. And all of this is according to Google. I got this from Google. So it's important to understand that a chlorination is the first reaction mechanism which includes a free radical. A free radical is, if so, you need to know the definition of a free radical, and a free radical is an atom or a molecule that contains at least one unpaired electron. So usually you get something like, so let me see if this works. So you get something like this, I don't know. So you have this here, this here, this here, this here, this here, this here. We don't have to draw all of this is usual. The only part that really matters is that you have one unpaired electron. And I'll explain why this electron will be unpaired. So usually you get these two here, which are, so all of them here, paired, paired, paired. And then usually the reason why you get Cl2 is because you need to get that covalent bond. And that you share those two electrons there. When you separate, the whole point of free radical is that you're separating that Cl2 into just two separate Cls, so 2 Cl minus essentially. It has a negative charge because the overall charge is negative, and this is very reactive. Free radicals are also very, very reactive because they always want to have that paired bond or paired, like they always like to be paired like this. They don't like to be unstable like this. So yeah, I'll get on to how this actually happens. So yeah, actually it's probably better to, I'll come back to that later actually. And we're going to be talking about that last one there. So the free radicals are split up into 3 stages. Probably change that actually. There we go. So you have initiation. Oh, let's do that. Initiation. So this is the process where I'll explain how you actually create the free radical. Then you have propagation. And that's the step where essentially your free radicals are substituting with non-free radicals and creating more free radicals. And then you have termination at the end, where essentially those free radicals are no longer free radicals. So your 2 free radicals join together to make a normal, your original molecule that's not original molecule, a molecule that's not a free radical anymore, a stable molecule, if you will. So I'm gonna come back to this point and then try and explain the first step, which is initiation. So chlorine is you've always found it as a diatomic molecule. So if I was to try and draw the kind of outer shell of it, kind of get this here. I know it's not a perfect drawing, I know it's not that good, but just bear with me here. Your Cl here. forget about how terrible the drawing is. The idea is that they can't be stable on their own. They always have these one electrons here, so that's what they need to have. Because they both share one electron, they can both share one electron to get stable. That's why I always find them like that. However, you can actually separate these by using UV light. UV light is really good at breaking this bond here and separating them into two separate chlorine free radicals. So if I just get introduced, this would be an initiation stage, by the way, and then so you get UV light here. Like using this example, I'll change it around. It's gonna be long. Yeah, here we go, that's much better. Right. So I'm gonna try and draw it again. So you have your Cl here. You already know it has the outer electrons there, so I'm not gonna draw that. And then you have bond here, and it'll be sharing some sort of electron there. So when you introduce UV light, this bond here becomes unstable and it breaks. So you get two separate free radicals here, so Cl and Cl minus. So it's two Cl minus essentially. So we're going from essentially Cl2 to make two C. That's actually terrible too. 2Cl minus. But you probably draw it as a, you usually represent free radicals as a dot when we're talking about free radicals. Again, horrible for me. So that's the initiation stage. And yeah, that's what you need to know for initiation. Right, so propagation now. So this is when, so there are often multiple propagation steps. So anyway, so let's talk through it. Multiple propagation steps. These involve free radicals and generate a new free radical. So essentially, you're gonna get your free radical here. So I'll probably, let me just draw the example here. So you're gonna get the idea is that after that initiation stage, you would have got this. Essentially, two of these. Almost forgot to mention, when you're drawing the breaking of the bond, you can do it as this as well. And then essentially, you now got two of them. Anyway, so the propagation step is when you get, for example, let's say methane. So if I was to talk about a reaction that we wanted to favor, chlorine and methane. With excess methane, we can get chloromethane, and with excess chlorine, we can get multiple reactions and end up with tetrachloromethane. So I'm gonna draw out. So I'm gonna get a start with methane. Actually, it's pretty easy one to do. So we get methane here, CH4 plus. Get one of the Cl minuses. So we want to get one. Let's get one of these Cls. And then that goes to make this here. This is the substitution reaction that we're going to get here. So CH3. And you're always going to get, with the propagation step, you're going to have a free radical in the reactions in the reactants and in the products. So plus HCl. So how is this reaction actually happening? So you have your Cl here. Very simple. It's going to get very much attracted to this. Always go from, and you always go from your negative to your positive. This will react here. So then this Cl minus is going to get very attracted to this H here. One goes there. So remember, this is what this is trying to do. Is trying to get. Is the bond's gonna go form go to fall to this H here because it wants to get stable. It wants to have a paired electron. That's why this bond goes here. So that electron essentially makes that pairs with this electron here. And remember also, I haven't drawn it here, but there's all of these ones here paired. So you get paired, paired, paired. So then this is the only one that's unpaired. That's why it's attracted to this positively charged one here, because then it can get this electron here. And essentially, you're going to get here is, as you see here in your reactants, you're going to get CH3. And then you're going to get yourself a HCl, hydrochloric acid. And then this, well, you can see here it's already lost. It's lost one free, one unpaired electron. That's your new free radical there. And there's another example I can also use here. For example, well, I can use that same CH3. I should probably put a dot there. So I can use that same CH3. The free radical. And then react that with Cl2. So I can react that with an excess of Cl2. And I can actually make CH3Cl plus a chlorine free radical like we already started with. So that goes to make this. Yeah. I can probably explain that again as well. So you've got this here. Yes. Cl. How I believe it should go is that this will get attracted to here. Yeah. And then I'm seeing this go here. That would make this here. Yeah. So this is the free radical. The free radical will go to the chlorine. The chlorine then because it's already got that bond there, it will break off of this chlorine here, so it can form a stable bond essentially. That will for a split second become a free radical, but just for a split second, for a split second that'll become a free radical, but it's so fast that it almost instantly becomes your CH3Cl. The only free radical that you have to worry about here is just Cl. That becomes a proper free radical because it got nothing. It's an unpaired electron that has nothing to react with. So essentially, you're gonna have your CH3. Let me go back actually. Here we go. Don't know why that's red now. And that Cl now is just on its own. But yeah, that's the propagation step. Now you've got the final step of the reaction, which is termination. Termination step is is one which involves two free radicals forming a covalent bond. It's said to, the idea is that it consumes free radicals, that after this final reaction there's no more free radicals, because you're getting two free radicals on the reactant side and then forming one molecule at the end, or like some, there's no free radicals on the product side. Essentially they're forming that one covalent bond together. So the relevant equations are, so let me just put that down exactly. So two free radicals on the reactant side. Yeah. So the idea of consuming free radicals and his last step. Alright, so let's get some relevant equations. So for example, let's get down, I was trying to turn back to this. We can just cancel this actually. Here you go. Let's have a new one. Alright, cool. So if we have two CH3s, so 2CH3, that can just go on to make C2H6, or essentially ethane. I think it's pretty clear how that happens. If you just got your CH3 here, so and then you got CH3 here. Those two are just gonna go pair. I think it's quite easy to see how it's gonna happen here. That's probably a bad example. But these two will bond. And I think it's quite clear to see, because you got your unpaired electrons here, and you just want to get paired, forming a covalent bond. It's very simple there. Another example I could have is 2Cl, 2Cl free radicals, and that goes to make again very simple. The concept is very simple again. These two are just pair, the same idea here, and I can get, see, one final example I can use is a methyl group and Cl. So you're always going to get two. I guess you could have three. Would you have three? Idea is that the entire of the left hand side in termination step, the entire of your reactant side is just going to be of free radicals, and your product side is just going to be well, just your product, your covalent bond. So this would be CH3Cl. And you got your Cl here. Yeah, I think it's pretty clear to see what's going on here. Anyway, so that's your termination step, and that's pretty much how the reaction goes on. There is one small part of free radical substitution that you may or may not need to know. You probably don't need to know it as much, but it's called homolytic and heterolytic fission. Essentially, what it is, because I know some people have no idea what that is. It's to do with the initiation stage, when the UV light is used to separate. In this case, your chlorine. There's two ways that it could happen. So, homolytic cleavage is the breaking of a covalent bond in such a way that each fragment gets one of the shared electrons. So if I was to draw it here, so if I get my Cl here again, homolytic would be each side gets an equal, because there'll be 2 electrons here, so each side gets an equal amount of those electrons there. And yes, so the 2 electrons would be equally divided. In heterolytic division, one side may get more electrons than the other. So it's if you know biology, or just hetero means homo means same, hetero means opposite, or kind of like not the same in a way. So if I was to do heterolytic fission, you probably don't need to know this, for example. You can get both of them going here, full arrow there, and then I guess, how does I draw this? I think that would probably be like this. I'm not entirely sure how to draw this. I'm not going to draw it, but the idea is that both the two electrons are going straight to here. And this wouldn't get either of them. I guess it'd just be like this, wouldn't it? And then nothing there, and then this would be a full atom like this. But yeah, that's something that if it ever comes up, you have an idea what it is, but unlikely to come up. So yeah.